Welcome to day 2 of MIT CDOIQ Symposium. You are viewing session 9E in the international track. I'm Carl Gerber, Chief Data Officer of Deloitte US. The MIT Symposium continues to expand our global reach with an excellent lineup of sessions that bring a world view. This is session 9E, Bridging Real and Digital Space and the Applications of Telehealth and Telemedicine, the Poland Experience. One of the fundamental questions that global wave of digitization seeks to answer is how to automate, simplify, and optimize the use of data. In order to enhance operational performance and to create added values in the process, every industry strives to control and harness data. And healthcare is no exception. Healthcare institutions realize that the most valuable asset in this digital era is none other than the massive piles of historical and transactional data that they have been storing and collecting, and which can be captured to connect doctors and patients remotely. COVID-19 also has demonstrated the healthcare system weakness in managing patient care remotely through telehealth and telemedicine applications. Rehabilitation, side effect management, psychiatric consultation, etc., remain unmet needs not only during the demanding COVID-19 period, but also in the pre-COVID period and in the post-COVID environments. The major elements to be addressed during this session include the Polish experience with the following: government policies and regulations in focusing telehealth and telemedicine applications, highlights of technical drivers for improving data management and system integration for the remote care of patients, controlling costs and improving treatment outcomes through teletreatment, understanding the challenges and market opportunities in Poland in big data and healthcare and their successful application to telehealth and telemedicine, selected applications to illuminate the gains in treatment outcomes and disease prevention from telehealth and telemedicine applications. A few session housekeeping items. First, this session is being recorded and will be made available along with all of the other sessions from the symposium post these 3 days. We do have audience Q&A available through the Whova app. Go to the Q&A tab and enter your question. If you see a question there that you would like to see addressed, be sure to vote it up. Now, I would like to introduce our moderator for this panel, Frank Ponzio Jr., President and CEO of Symbolic Systems. Frank is a thought leader in the fields of military and commercial information quality. He has received U.S. patents related to information quality and presented his military information quality experiences at MIT symposiums. He founded and was the president and CEO of Symbolic Systems Incorporated, a pioneering company in transitioning manual military and business processes to computer processes, to which he founded in 1968 and sold 47 years later in 2015. He specialized in military DQIQ improvement in the fields of ballistic missile accuracy, the real-time sharing of biometrics data with national and international organizations, and in uploading of various types of weapon systems information for warfighter deployment. Frank, over to you.
Next chart, please. I'm Frank Ponzio, and I'm also President and CEO of the People Technology Foundation that I do a lot of my publications through. The session, next chart, please. The session 9E team thanks Dr. Stuart Magnick and Dr. Rich Wang for this premier symposium. Thank you to Robert Lutton, Carl Gerber, and members of the CDOIQ team, whose motto is "Teamwork makes the dream work," for helping us to prepare for this session. I have had the pleasure of being associated with Dr. Rich Wang and Dr. Stuart Magnick of MIT for over 20 years. This association has been beneficial to the direction and growth of Symbolic Systems and to me personally. The intent of this session is to provide the symposium attendees insights to how Poland has approached handling the collection and sharing of high volumes of medical and data for telehealth and telemedicine. George Handy. George Handy is a U.S. veteran and previously with the U.S. Center for Strategic and International Studies, CSIS, where George and I worked on projects in Romania and Poland. George Handy has been a pioneer in developing cooperation in medical and other areas of scientific and economic growth in Central and Eastern Europe. Dr. Cezary Mazurek. The Poznań Supercomputing and Network Center in Poland is known internationally for its technology R&D and technology application achievements. I found it very interesting that their achievements include providing doctors data analytics for a disease. We are fortunate to have its Chief Operating Officer and Director, Dr. Cezary Mazurek, on our panel. Dr. Raul Palma. Raul has been more than 16 years of experience in research and development in different areas related to artificial intelligence, and including knowledge representation, semantic data, integration, discovery and reasoning, open and linked data, and the application of semantic technologies in different domains. He is currently coordinator of the H2020 project called Reliance, RELIANCE, which will extend the European open source cloud called EOSC with an enhanced support for research, lifecycle management, and earth science in the line of FAIR, F-A-I-R, and open science principles. Dr. Marcin Herzog. Interestingly, we have a medical doctor on our panel. Dr. Mazurek will provide us with the impact on patients and physicians of the data applications we identify. Marcin has been a senior executive in the healthcare industry for over 20 years and currently leads a nonprofit foundation in Poland for innovation in healthcare and other sectors, as well as treating patients. We look forward to your questions. George Handy, turn it over to you.
Thank you, Frank. Next slide, please. My brief remarks will describe the setting for our presentation and our three aims. I've worked with Central and Eastern Europe, as Frank mentioned, over a period of 27 years, and Poland's been the cornerstone for this type of work. Although growth in Polish-American cooperation has been our goal, we feel that this cooperation gains from our support for Poland's growth as a member of the European community and also for Poland's cooperation with countries worldwide. Next slide, please. Poland is the setting for our presentation today and has been the target for collaboration within the team that's making this presentation to you. We believe that Poland offers high credibility for the description we'll present of applications of data management and information quality to healthcare for the following reasons. First, Poland describes a strong, or provides, a strong economic and scientific base for growth in areas such as healthcare. As indicated in the first two bullets, number one, modern Poland has had positive economic growth for each year since the end of the Cold War. Additionally, although below the OECD average, Poland's investment in research and development has grown every year since 2005. In addition, Poland is committed to healthcare, data management, and IT, as reflected in the three final bullets on this slide. The Prime Minister's emphasis, as indicated, on innovation in healthcare that was taken this year matches other recent commitments that justify recognition that healthcare in Poland is a priority. While I could offer various statistics on data management and IT in Poland, I believe that our presenters and their messages will earn your confidence of Polish excellence in these areas. Lastly, healthcare and data management in Poland are advanced particularly by the talented and educated workforce that Poland provides. As indicated on the slide, the status of Polish university education, I think you'll agree, is a meaningful indicator. So we believe these advantages support a robust capability and market for health and remote care in Poland that merit your attention. Next slide, please. Our three aims are indicated on this slide, beginning in the box on the left. Cezary Mazurek will focus on the data processes being employed in Poland to address today's challenges in healthcare. Next, Raul Palma will emphasize data management and integration as it takes place in Poland, with attention to connections between physician and patient. And third, Dr. Marcin Hanczaruk will present conditions that exist in Poland for, as well as data applications for telemedicine. Now, these three aims contribute to the overall goal of improving the quality of healthcare for Polish citizens, particularly those with limited access benefiting from telemedicine. We believe these merit the attention and support of the CDO for application elsewhere. Next slide, please. It's my pleasure to introduce my friend, Cezary Mazurek, who will address the first aim of our presentation. Cezary?
Thank you, George. Good morning, everyone. Thank you very much for inviting me for this panel. And I'm going to show a little bit of strategies and examples behind this strategy, focus on addressing the challenges of massive piles of data supporting research for healthcare in Poland. Next slide, please. So introducing myself, the most often question I have been asked for more than 15 years of collaboration between our center and US partner is how to pronounce my name. So my name is spelled like Cezary. It's difficult for US friends to spell hard C, but it is like it is pronounced in a Polish language, which is of course not very easy language to speak. I have started working at PSNC in 1993. It was the beginning of PSNC. And in this year, we've been appointed as the first 6 team members, first 6 employees. Currently, we have 420 people on board and really big center, recognizable in Europe and worldwide as the research center and e-infrastructure or cyber infrastructure operations. The problem I faced for those more than 25 years is my daughter's questions. Daddy, what do you actually do in this job, in your job? And I have been trying to answer this question for many years. And 10 years ago, I started to deal with challenges in medicine to have something to say over family dinners, because my daughter, my son-in-law, my wife, they are all working in the hospital, and my younger daughter, she is studying medicine. So I became the only person who can change the topic at the family dinner. Next slide, please. Today, I want to present you a little bit of feeling what we are doing in Poland in terms of addressing the massive challenges of massive data processing and aggregation in a way that I will show you how can our activity be described why we actually observe Deloitte Tech Trends or Gartner Magic Quadrant or other technology trends. What are the benefits of working together in Europe? We have very strong collaboration in Europe, and Europe funding is driving research in Europe. And finally, I'm going to stop a little bit more on healthcare, our emphasis on data management and integration towards better diagnosis and treatment for the patients. I will give you project examples. Next slide, please. So PSNC stands for Poznań Supercomputing and Networking Center. And when we look on the most lower line here, we've been presenting ourselves as data-driven organization. That's mainly because in Poland, we have continuous financing for cyber infrastructure for more than 25 years, and we have 21 metropolitan area network supercomputing centers, national research and educational network, which is the associated member of Internet 2 in US. So this is the infrastructure power we provide for data processing and data organization. We focus on platform architecture and service design. This is mainly because in Poland, we have the Polish roadmap for research infrastructure, and PSNC is involved in 11 out of 70 of those projects, not only in digital area, but also in other domain specific like medical or biological infrastructures. And finally, we build the value added on this research infrastructure thanks or mainly due to the financing obtained from the European research funding programs with 295 international research and educational development projects. Sorry. Next slide, please. So one of the key pillars of our activity is our research and educational network. We are operating the national backbone network. This is the fiber optic cable network, providing the connectivity to all the scientific communities and institutions in Poland, also providing the connectivity to main data exchange point in Europe, including CERN and other data exchange point over the Europe, connecting through those points to global research networking. Next slide, please. So why we are looking at those trends and why we are looking at data-driven challenges at all? First of all, we are focused on the infrastructure operations, but we are our blood, our air is the research in information and communication technologies. So to provide the real outstanding infrastructure for researchers, for industry, for society, we need to focus on the technology trends like those mentioned by Forbes a year ago or others, and address those trends in developing of our infrastructure. Those examples are, of course, artificial intelligence and machine learning, computer and machine vision, genomics, but also such technologies like 3D printing or digital twins or 5G networks. Those all are the areas which we are targeting in our research and development works. Next slide, please. When we are looking at the Deloitte report, providing the challenges, top challenges which organizations face in implementing digital technologies, we find that on the left side in Europe, on the left side chart, it is presented three top challenges. First two are more organizational and economics, so bureaucracy in healthcare and cost of technology. But the third one is our target of activity. So we need to support future technology or digital transformation addresser with the competencies of finding the right technologies to address their challenges. This is what we are doing in healthcare, but not only, in many other domains like agriculture and many others. But with the technology background and infrastructure provided for our users, we can address the gaps which are pictured here on the right side of the slide in three out of 5 areas. So we are addressing these gaps by providing the infrastructure, providing the leadership in Polish digital transformation of healthcare, and providing the interoperability platforms addressing the challenges of data acquisition, data integration, and also the data and knowledge processing. Next slide, please. Poland is fortunately is a member of European Union. European Commission is providing the financing mechanism to address those challenges. And the newest strategy, which Europe's put in the digital strategy, is the pillar focus on data strategy or common European data spaces. As you see on this picture, on the bottom level, on the bottom row, we have the technical infrastructure, which is the key pillar of addressing the different personal data spaces areas in Europe. Health is the most on the most left side, but there are others like agriculture, finance, Green Deal, or energy, which will be addressed in following 7 years. But the key point is that those areas have to be glued or have to be addressed with the development of information and communication technologies, which our center is focused on. And this brings the overall picture of how we address the European strategy on data spaces. Next slide, please. One of the examples of such a platform or such an activity on European scale is the National COVID-19 Data Hub, which we are providing or contributing to European COVID-19 data platform. When we store the semi-species of SARS-CoV-2 viruses and based on those semi-species genomics map, we are providing information how the COVID-19 was developing over Poland, over regions of Poland. What are the sources of those semi-species and where the main exchange point or the commutation point in the area of regions, cities, and the countrywide. Next slide, please. So we have many projects, and projects are actually the main driving points, main driving forces of our developments. We focus on obtaining the funding for those projects, and all of those I'm not going to mention, but I will focus on 2 examples, the last 2 of this list. One is the example of the platform focus on the intelligent data management for exascale computing, and the last one is the example of diagnosis diagnosis and treatment support system for ophthalmologists. Next slide, please. So Admire is the project which just started in April this year. And this is the European funded project with the 7.9 million euro, which will focus on the quality of service, energy efficiency, and resilience for accessing extremely large data sets in very heterogeneous computing and storage environments by creation of new architecture, new active input and output stack, which will be able to dynamically adjust computation and storage requirements through coordination of requirements and computation resources. This project is coordinated by our Spain partners, and this project brings on board leading high-performance computing centers in Europe. Next slide, please. So there are several motivations behind this project. However, the 2 first and last 2 are the most important for our center. First of all, that today the data processed in a infrastructure like high-performance computing needs a new architecture and new software stack to address the big data applications and address massive pile of data, including healthcare. So we are focusing on integrated processing of data in motion and data which are stored at rest, which are in this project addressed to overcome some barriers which we have today. Artificial intelligence and deep learning are among those applications which are now driving as a driving force to a new class of workloads which need to be studied with regard to their data management, storage, and I/O needs. So we addressed in this project. The next slide, please. And PSNC is providing the use case to check these new architectures with a specific brain super resolution imaging application, providing the data from microscope images or from the external data repositories, and providing the tools to reconstruct the super resolution images of brain from slices, discovering differences between the images of healthy and ill patients using machine learning. Next slide, please. This is not the only one use case. The platform itself is it's provided for 6 use cases with turbulence simulation or molecular dynamics or weather forecasting among them. And next slide, please. The second example of our healthcare application is focused on the personalized medicine. The personalized medicine we understand as the ability to adopt therapies to an individual patient profile. And this is actually the challenge which we try to address by building the mathematical models of human organs, but also by building a model of development of pathological changes. And this is the real key of this example. We, of course, use the machine learning algorithms to predict the development of the disease. And we need to remember several problems and challenges which in this process, based on the infrastructure and competences Poland have already very broad, that high degree of complexity, we deal with high degree of complexity of described reality. We deal with a high degree of dependency between different variables because we are talking about human body, about the very complex system. We need to be able to interpret decisions of the medical doctors and assess the model reliability and quality of data. Next slide, please. So what we are doing, we have the ophthalmologist on board in our team in the project who is providing us with the 2 kinds of continuous 24 hours monitoring data. One source is that our data collected from a Symposium triggerfish eye volume measurement device. This device is providing the data like on the top chart for 24 hours. Different ocular pulse amplitude is measured, and during the wake and during the sleep phase, with different artifacts, like for instance, eye blinking during the wake time. And we have to deal with this data and ensure that the quality of this data and synchronization of this data source is managed. This is the first example this is the first data source which we collect. And the second data source comes from the next slide. Next slide, please. Yes, the next slide. Yes, sorry, one way. And the second data source are data collected from the cardiovascular monitoring system, which provides the data in the same time frame, 24 hours, on the patient activity, position, heart rate, systolic and diastolic pressure, as well as saturation and other cardiovascular parameters. Those two data sources are collected by the physician, by the practitioner, to address the problem of early diagnosis of glaucoma disease. Glaucoma disease is quite a popular disease in Poland. More than 5% of the population are in the risk cohort. And that's why this is very important for the practitioners. This is a very important disease to address it very early before the real symptoms will be visible in the eye nerve. Next slide, please.
2 minutes,
so why,
please.
Yes, why it is important? We have to deal with feature engineering in this process. We need to provide the different parameters because the data is in a massive pile for 24 hours, lots of measurement points. So we are looking for some attributes which can describe the real physiological symptoms or processes instead of artifacts. We are trying to measure the correlation between those attributes and many other engineering data analytics procedures, which we do together with the practitioner, with the ophthalmologist. Next slide, please. For this analysis, we provide the open source platform for machine learning and data and massive data analysis. Next slide, please. And the result of the application is the first result of the application is the data analytics. So it allows ophthalmology or any user to assess the selected patient group and measure the and check the parameters value. And on the next slide, please. And then finally, after uploading the data from the patients, it allows to predict the diagnosis on the platform for diagnosis hypothesis refinement and provide information whether the patient is in a safe state or it may be predicted to glaucoma. Next slide, please. So what are the challenges we face and for now and for future? First of all, we need to address the number of cases to analyze and to deal with this proportion between the parameters and the size of the set to analyze. There are lots of different parameters, not many patients which can be measured. And so the data analysis and the reduction of data is the key point to find the right environment to work with the physician, with the practitioner. The data mining tools are to determine the parameters of case description. We need to strictly control this process by physicians' expertise. We need to listen to them and be able to talk to them. We need to challenge the feedback effect. So we have the model, and model is based on the medical knowledge and interpretation of physiology based on the work with data and models. So practitioners need to learn also this process, and we need to base on their feedback. Then we have to assess the model reliability and the validation of results. This is the key point because we need for this phase the new patient set. And finally, for the future, we now are focusing on transition from the level of diagnostic to the proposal of therapeutic intervention for practitioners. So our platform, our system here is focusing or is bringing data to practitioners in the terms of valuable platform to assess the risk of glaucoma. Thank you very much.
Thank you, Cezary. Thank you for highlighting the strong foundation that Poland has established in order to address through management tools and state-of-the-art technology, the massive amounts of data that confront many different areas of activity, but particularly are demanding for healthcare. Now it's my pleasure to introduce Dr. Raul Palma, who will address the second aim of our presentation and move us from this strong foundation in Poland through data management and integration towards the linkage remotely of patient and doctor. Raul?
Yes, hi, thank you, Frank, for this, George, sorry. Yeah, so I will start my presentation with a high-level overview of the topic that I will be addressing here. So if you go to the next slide, please. So basically, we are going to focus here on the challenges in data management, with focus, of course, on the use cases in telemedicine. Then we are going to discuss a little bit on how we are addressing those challenges of data integration, especially with the use and help of what we call the knowledge graphs, or what is commonly known as knowledge graphs. Then we are going to one step further on that and trying to explain you here all these practices that we are having in Europe, but also particularly applying in Poland, and how to move from data and other digital objects to interoperable fair digital objects. I will talk about that in my slides. So, and then how going from those fair digital objects into fair aggregations of digital objects. That is something that will allow us to encapsulate and to organize all resources related to some particular process or some particular investigation. And finally, I will just show you some example of how we are making this kind of representation of fair digital aggregations using the concept of arrow crates. So next slide, please. So yeah, starting with some kind of high-level context here, data process intensive science are increasingly consuming and generating different types of digital artifacts during the course of their investigations or their processes, which are in general valuable resources during the practice, for example, in telemedicine. And most importantly is that all of these artifacts, as you can see at the bottom of the slide, are typically stored, distributed, and they are stored in different repositories, probably following different access and distribution policies and so on. So we are ending up with a scattered set of resources in different places. So that's normally the situation that researchers and practitioners need to deal with. Next slide, please. So for example, if we go into the case of telemedicine, we know, particularly after consequence of the COVID-19 pandemic, that this has increased dramatically during the last year, especially because it provides some very good benefits, like reduce risk of infections, particularly in seniors or patients with chronic diseases and so on. In addition to all these general benefits like the telemedicine can provide, like even addressing the shortage of the workforce or practitioners in particular places. But this kind of new and more engagement into the telemedicine has also make a kind of shift in the way that we are handling the data. So as you can see in this diagram here, this is showing you how the pre and post COVID process of telemedicine works. Basically, you can see that there is a lot of data here. So the patient engagement is increasingly digital. So there is a lot of data that is collected, that is produced during the course of this process of telemedicine. And again, these kind of artifacts might be in different places. They can be, for example, even in your own laptops, computers, or in the institution that are different from the other institution that is dealing with some other diseases and so on. So this is the situation that we are trying to deal with. So next slide, please. So this leads us to the explosions of data, basically, as I was just trying to convey in the previous slide, and which is actually one of the biggest challenges, not only in telemedicine and in the e-health in general, but in many other different domains that we are also addressing in PSNC here in Poland. So basically, these challenges comes because data are normally provided and generated in different formats. They are using different models to represent the data, and even more, the semantics that are used to represent or to represent the data according to those models are different as well. So it's very difficult to have a high-level view of all the data that is scattered across different places because of these challenges that I am just highlighting here. In addition, there are insufficient mechanisms to allow the interoperability of the different models. So as you can see here, there are some examples of some well-known companies like Green or Leavenworth that highlight those challenges. For example, in data challenges in telehealth, one of those particularly is related to the integration in interoperability. It's in the middle. So it's really important one. Similarly here in the healthcare interoperability challenges, you can see all the different aspects that are related to these challenges of interoperability. And even more, as I was saying, so this is a general, a challenge. Even in a recent Gartner survey, we see that 50% of the data and analytics leaders want to entirely automatize the process of data integration. So, how to have this kind of high-level overview of different data. Next slide, please. So in Poland and in PSNC particularly, we are addressing this with the help of knowledge graphs. So knowledge graphs provide a flexible and efficient solution to address some of those challenges. They are providing like a structured data model or topology that allows you to integrate data, describing and publishing the entities and the relations between all of these entities as the so-called linked data. Linked data in general is very simple in technical terms, is providing a simple set of principles and use of technologies, how you can represent data as linked data. So it's based on typical technologies like HTTP, URIs, but also some kind of semantic technologies like RDF and SparkWeb. And it's becoming one of the most popular methods to publish data on the web, particularly because it has many benefits. On the one hand, it improves the accessibility to the data by both humans and machines. So this allows for things like data integration, for example, but also it allows you to do some kind of knowledge discovery, so kind of reasoning or discovering knowledge through the links and that kind of thing. So it's very popular now and it's becoming bigger and bigger around the world. Next slide, please. So as we started to apply these principles of linked data into all of the different projects and scenarios that we have been dealing during the last years, we of course realized that there are a set of repetitive tasks. So there are very similar tasks that you have to address during this process of generation of linked data and knowledge graphs. And so based on that, we designed and implemented what we call the linked data pipelines. That allows the transformation from sources that are scattered or are distributed and that are coming from legacy systems, and the transformation of those data into linked data format, including the connection of these data sets in order to provide at the end an integrated view on top of all those different data. And this is here the implementation links as an example of what we are doing in PSNC. Next slide, please. But going further from that, I mean, there is also the need for allow also the data and other digital objects to be interoperable themselves. And this is, again, a global movement that is based on the so-called fair digital objects. That is a unit composed of data, but also metadata that is regulated by some schemas and that is having some assigned persistent identifier, which make it fair. Fair means that is findable, accessible, interoperable, and reusable. So these are the main principles. This is, like I said, global movement, but especially in Poland and in Europe and in Poland, we are very much strong following those kind of principles. And in particularly, these fair digital objects can be at different levels of aggregation. So you have its own, a digital object in its own as a fair digital object, but you can have it also as an aggregation of digital objects itself. So, there are different levels depending on the granularity that you need. Next slide, please.
2 minutes, please.
Yeah, so, okay, so basically here, the first digital object has some kind of information like I was showing in the previous slide. So one of those is the metadata. The metadata is critical to enable this interoperability. And we have different levels of metadata that allows to do some kind of the technical interoperability, semantic interoperability, organizational, and legal. In here, for example, I'm just focusing on the semantic interoperability that describes metadata at the level of the framework, at the level of the classes of the objects, at the level of the object representation, at the level of the object itself, and the provenance about this. So yeah, next slide, please. So now that we have like knowledge graph for data integration, we know about the fair digital objects. So how we are actually being able to provide a unique entry point to all of the resources that are related to some particular process or investigation, like in, for example, a patient data or a telemedicine process and so on, and how to capture the life cycle or disseminate this knowledge. If you go to the next slide. And this is what we are doing with the so-called research objects. This is self-describing chiefly metadata objects that are based on three main principles: unique identifier, that are making them citable; aggregation, which you can put anything inside the research objects; links to resources that are scattered across different places; and annotation, that means metadata about these resources or about the research object itself. This concept of research objects has started like over 10 years ago. We have been involved from the very beginning on that. And right now, the latest trend is the so-called RO crate, which is like a lightweight approach to package the research objects and make it exchangeable and interoperable. Next slide, please. So in our case of telehealth scenario, for example, if you see all of these entities and resources that are being generated in this healthcare ecosystem, this can be actually, aggregated and collected into one e-health research object that can then allow an easy and integrated access to all of this information, providing like an entry point to all of this scattered information. Next slide, please. And finally, I just show here in PSNC, we have, of course, an implementation providing the technological support for that. And this is called RO Hub, which allows, to organize and describe resources based on research objects to enhance the findability of these resources, manage their life cycle, assess the quality of these objects, make some recommendations, and do some kind of enrichment based on the semantic metadata. And with that, I am finishing. Thank you very much.
Thank you, Raul. Thank you for taking us from the strong foundation for data management and IT that's applied to healthcare and introduced by Cesare to your presentation of the tailoring of those tools and their application to telemedicine. Now we move to the user perspective, and it's my pleasure to introduce my colleague at the Alliance for Innovation Foundation and my good friend, Dr. Marcin Hanczaruk. Marcin.
Thank you, George. Good morning, good afternoon to all of you. I have to say that this is a unique pleasure to be part of that symposium. Before I jump into my part of the presentation, I'd like to share with you some remarks that I believe are important from the practitioner perspective. So first of all, what we see in Poland, but probably worldwide, is a true acceleration in innovation in healthcare. That's driven by many factors. The one of those is we continue to better understand the biology of the cell, whether it's a tumor cell or physiological human cell. We also face the new dynamics like aging population. We also faced recently the COVID, which from my perspective was a game changer and clearly demonstrated a number of unmet needs in the area of healthcare. Can I have the next slide, please? So my objective is to provide you with some helicopter view and add on what's been already said by my colleagues. So what is happening in Poland regarding the telemedicine is a true acceleration. So if you look at the left upper box, more than half of the medtech startups in Poland are active in the telehealth and telemedicine. And this is the largest group, which is followed by startups and companies in AI, machine learning, coming as a second, a medical device in the third. If we move to the right, many of the projects are now in a pilot demonstration phase or test phase. This is very much supported by the EU and Polish government funding, different R&D grants, seed venture capitals or accelerators. Then moving to the left bottom, we have already, on top of some early stage, companies and projects, we have already mature ones that are already on the market and they are ready to scale the business. And there are some examples, including the Doc Planner, which is an app for booking of visits, Telemedical online visit, Intermedica online symptoms checker, NestMedic, which is CTG solution for fetal health, Stetomy, which is smart stethoscope, HyoSense tool for comprehensive medical examination. But also on top of what is happening locally, I would say, there is a significant interest of global players, including Google, Microsoft, or AstraZeneca, that are very active in the Polish market. And their activity includes also building an ecosystem where the startups and innovators in the life science could test their projects and innovations. Next slide, please. You know, this bus, which is happening that I just described, is also supported or paralleled by the initiatives coming from the Ministry of Health and National Health Fund, which is a payer. And basically that the strategy of Ministry of Health covers different levels. Obviously, we have national initiatives, regional ones, but also the local ones with the aims of supporting the relationship between a physician and patient. But also there are some discussions in pilot tests, including virtual hospitals, and hopefully one day we'll see the full virtual hospital that will be providing healthcare services, obviously to the extent that is possible to the patients. Next slide, please. Well, so as I said, clearly we face the telehealth revolution in Poland. About 97% of healthcare leaders have expanded the telehealth access and initiatives since COVID-19 outbreak. So they're using different solutions that can be beneficial for both for the patients, but also for the companies. And there are just a few examples. PZU, this is the state-owned biggest insurer in Poland. Unmet, this is one of the biggest privately held biopharma companies. They are actively looking for highly scalable solutions that will improve self-diagnostics with emphasis on remote usability, remotely monitoring of patients with chronic diseases, proactively addressing the needs of elderly patients, making the diagnostic and therapy process faster, simpler, and obviously more cost effective. Next slide, please. Okay. Yeah. And those are just, a few examples. So Telenan, this is a telecare model for neuroendocrine neoplasm management in case of Meckel's diverticulum net. So this is kind of a rare disease. So what is happening here, the telemedicine is used to collect the, knowledge and experience from all the centers and individuals that are dealing with those patients to optimize and accelerate the diagnosis of those patients. Next slide, please. This is very interesting example from the company. This is Warsaw-based company that is dealing with VR. They created, on the request of US Department of Veteran Affairs, a training, virtual training, dunning and duffing, that was extremely highly ranked by VA leaders, and actually was used and implemented. The nice thing about this cooperation was that the team in Poland has managed to put together the whole training program just within a couple of days. And especially at the early stages of COVID outbreak, the speed and timing was just key. And next slide, please. This is again, this is what Immersion has put together for VA. Next slide, please. And this is another example from the cardiological center. For the majority of the patients, they change into the remote controlling of symptoms and regular monitoring of patients. Next slide, please. And thank you very much. So that was the helicopter view I'd like to share with you. Thank you.
Thank you, Cesare. Please, Marcin, excuse me. And for our last slide, it permits me to say thank you to the audience for your interest and attention. We welcome your contact at any time in the future to share ideas and insights on this important subject as applied to telemedicine and the responsibilities and actions of the CDO. We will look forward to your questions. I'm afraid there's not a lot of time left, but with the time remaining, please, Carl, pose any questions that you have.
Yes, thank you, George, and thank you to our panel speakers. We have one question that has come in from the audience. An underlying theme that we heard through all of your presentations was how you're using innovative applications, tools, and appliances in homes and workplaces to augment the telehealth interactions. Can you speak to the trends and the pervasiveness of, and do you foresee this continuing at a rapid pace?
George, if you don't mind, let me start. Thank you. All right, certainly my assumption is that we not only continue to see the rapid progress, but probably we're gonna face an acceleration due to the reason I just mentioned. And when I think about from the practitioner perspective, when I think about IT and healthcare, certainly there are at least 4 levels that can strongly benefit from the innovation that is happening. First one is obviously the patient's level, so patient's care optimization, and telemedicine, telecare plays here a significant role. Over the COVID months, we faced a number of challenges. For example, oncological patients that who, because of the restrictions in hospital access, they couldn't have a proper oncological rehabilitation. My area, which is psychiatry, again, teleconsultation was of the essence for those patients during the COVID, and having a kind of an access to professional consultation. So optimization of the patient's care, this is one big puzzle. The other one, obviously, is cost optimization. And this is especially important from the payer's perspective, including Ministry of Health, including National Health Fund. So whatever can be done remotely versus in the hospital certainly will provide cost optimization and release some resources that are needed for different needs. The third pillar would be the research. Certainly, you know, this innovation would help from the research perspective, introduction of the new medicines, new technologies, new approaches, etc. And the final one, last but not least, certainly, it's improving the training and the capabilities building among professional healthcare professionals, specifically medical simulation, which is the future of medical training. So that would be my input to the question. Thank you.
And we have time for one more perspective on the trends towards using applications and appliances in telehealth.
If I may ask George, I think that I used to compare the situation we have now to the weather forecasting problems in the 70s. Today we can observe the people and their health as we were observing the weather looking into the sky. But for the attracting the massive data piles, we need to build the digital models to let practitioners to answer their questions about the forecasting, about our healthcare, and the forecasting on the individual parameters for disease development. This is the challenge which we need to face in the near future.
All right. Well, thank you to our panelists and Frank and George, our moderators. This concludes our session.
Done is right.
You are in the meeting room and
The biggest challenge in data analytics is that projects are failing.
Okay,
Gartner
folks,
estimates
you're
that
clear.
50 to 80% of all.
Wait.
All right. Well done, everyone.
Thank
Thank
you,
you, Carl.
Carl.
Thank you. Look good. Look good, sounded
Thank you.
good.
Very good. Everybody did. I was so pleased to see the whole presentation in its entirety that way. It was just phenomenal. Everybody did a great job. Thank you,
Thank
Carl,
you,
for your
Frank.
help.
Thank you, everybody.
Yes, and I think bigger than the presentation is the actual work and the impact that you're having in Poland. I think that is just tremendous.
Isn't it amazing that they're going down to a specific disease like glaucoma? I mean, that is just marvelous to have that kind of data analytics available.
Yeah.
I think
They actually think is that we are on the way to apply for patent solution for the diagnostic device over Poland, over Europe, US, and Japan for now. So this is quite an advanced solution now, and we hope to go to the business model based on this. By the way, Carl, you may want to know that we have partnership with Deloitte Poland in building the innovation solution together with them based on the SAP and other data management solutions. So Deloitte is our well-recognized partner here in Poland.
Well, I'm so glad to hear that. If there's any way I can help, let me know. I did see the references to the research that we do and publish, so I was very pleased to see that.
Yeah, we are on the continuous observing, and your technology trends reports are really good for us, and we are meeting those challenges. So I hope Poland will appear in the near future in the case study reports, because it's still they still lack some solutions from Poland, and I think we can give some examples of digital twins or healthcare or other technologies if coming from Poland. So I'm working on this with my friends here in Deloitte.
Oh, that's great. Yeah, you'll have a lead client partner there who could really facilitate that.
Hopefully, it became clear to the audience as well that in addition to the partnership between practitioners and data managers, and as Cesare and you have just highlighted, the collaboration between the business in the US and businesses like Cesare's in Poland, there also is a pretty good collaboration among government, university, business, both in Poland and internationally. And it's been successfully facilitated by nonprofits like the one Marcin has organized in Poland and has been operating pretty successfully, as you noted, in the area of healthcare, but reaches beyond that.
Yes, you're
That's
right.
really great.
And just one comment on this, it's really difficult to squeeze half of my life in 20 minutes. Sorry for having, I'm having half of the life on this, what I'm describing. So this is really difficult to put it in the one pile.
Whenever
Frank,
you
sounds
talk
like
to
you
your
have a
wife,
reason.
she will help you to put it in one slide, Cesare.
Frank, sounds like you have a proposal to get on the agenda for next year.
Definitely. This was what's really interesting. I put this on the agenda last August when I put this topic on the agenda with Rich and that was August before the whole thing broke out. And now seeing what they're doing and seeing what the world is today, it's just going to be amazing.
Yes,
They're really in the right place at the right time, if you want to use that phrase.
sure. Again, I'd like to thank you all. I do need to end this session so we can prepare for the next group who's coming in. You were very well prepared, and I hope you get a lot of views on the replay.
Okay.
Thank you.
Thanks.
Thank you,
everybody.
Carl. Thank you,
Thank you,
Frank.
guys.
Thanks, Frank.
George.
Have a
Welcome.
good day
Thank you,
and
everybody.
enjoy the symposium. Yeah, bye.
Thanks. Bye-bye.